Welcome to the video covering Chapter 4, Parallels, Lesson 6, Writing Equations of Lines. By the end of this lesson, we should be able to write and graph equations of lines. So let's start with some vocab terms. A linear equation is any equation whose graph is a straight line. Notice that the word linear has the word line in it. And the y-intercept is where the line crosses the y-axis. Let's take a closer look at the y-intercept. These are both lines. Okay, we have a purple line and we have a green line. The y-intercept is the place where the line crosses the y-axis. We have to remember that the vertical axis is the y-axis, the horizontal is the x-axis. So I can go ahead and label that. This is the x-axis, this is the y-axis. So on this y-axis here, the green line is crossing down at -1. The purple line is crossing up at +6. So it's that number on the y-axis that the line is crossing. There are several forms for linear equations, and we're going to focus on slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope, and we learned that in the last lesson, and b is the letter that's used to represent the y-intercept that we just discussed. X and y come from the coordinate plane. Remember that each point on the coordinate plane has an x and a y value. So this point over here would be the point 7, 3. This is the x value, that is the y value. So whenever we are using the y and x for the points, for slope-intercept form, we just need to remember that the x and y can change because it could be any point on the line, specifically, not just any point on the graph, it has to be on the line, but they change, so we keep those as variables in there. This slope and y-intercept are specific numbers that apply to each line, so they will change. So let's move on to focusing on how to graph an equation in slope-intercept form. There are 5 fairly simple steps. First thing we need to do is rewrite the equation in slope-intercept form, y equals mx plus b. Then we will graph or plot where the y-intercept is, so that point on the y-axis. We will then count the slope, so we are going to use rise over run to find where more points are. And we will plot them. So it says to plot the second point, we're going to plot at least 2 or 3 points. But actually, keep in mind that we only need 2 points to make a line. So as long as you have 2, we should be able to then connect the dots to create a linear, or a graph of a line, so a linear equation. So before we actually start graphing these equations, let's go ahead and practice actually finding the slope and the y-intercept. So reading these slope-intercept form or linear equations. So we have y equals, I'm just going to write right underneath it, y equals mx plus b. So according to that, +5 is my b, and the +3 is my m. So m equals 3, my y-intercept equals 5, and we're done. And so whenever the equation is already in slope-intercept form, it's pretty straightforward. So in this one, we want to be careful about that 2 is negative, and there is no written number in front of the x, so we have to remember that that's a 1. So m is going to equal 1, and the y-intercept will be -2 in this case. Now, if I take y equals mx plus b, and I write it underneath this one, well, this does not match. So this equation is not in slope-intercept form, so that has to be changed first. So in order to do that, I'm going to subtract x from both sides of the equation. So these x's cancel out. I'm left with y equals, and I'm going to move the x first. I'm moving the x first so that way it's in slope-intercept form because it's mx plus b. It's not b plus mx. So that's a negative x, so I kept my x negative, and it's negative from my subtraction. But this 4 is positive, so that needs to stay positive with a +4. Please don't write this as x minus 4. That subtraction belongs to the x. The 4 is positive. So this is slope-intercept form, y equals mx plus b. So now I can write that down underneath it and match up that +4 is my b value, and -1 there is my m. So m equals -1, and b equals +4. So in these three examples, it looks like they all need to be changed because none of them are y equals mx plus b, y equals mx plus b, or y equals mx plus b. So let's go through and change all of them first with some algebra, and then we will look at what m and b are. So let's just do a real quick walkthrough of what I did. Subtracted x, then I divided by -2. There's a -1 here, divided by -2 will get us a positive 1 over 2. Subtracted 7x from both sides, divided by 3. And notice again that whenever I do my subtraction of x, I'm always like squeezing it in front of the constant. Like I want my variable x to be first. So though I wrote 12 minus 7x here, that minus 7x has to be in front. You cannot actually subtract 7x and 12 because they are not like terms. So I just wrote it down and then I divided by 3, and so -7/3 x plus 4. In this one, there were two things I had to move away from the y by addition or subtraction. So I added 2x and I added 8 at the same step because they don't affect each other. So this -8y comes down and I'm left with 2x plus 8 on the other side. Divide everything by -8. 2 divided by -8 simplifies to a -1/4. And then 8 divided by -8 is -1. So using that information, our slope and y-intercept are as follows. You really just want to be careful with your positives and negatives with your slope as well as your y-intercept, but these are your answers for the m and b for these linear equations. And now that we have practiced identifying m and b, we're ready to graph because those are the only two values that we actually need. So in this equation, our slope is 2 and our b is -1. And even though I wrote down the -1 first, this is actually where we start. This is our beginning number. B is our beginning. It is where we're going to start. So I'm going to put a dot at -1. And then when we count using the slope, you have to remember that the slope technically it has to be rise over run, which is a fraction. So m, the slope, is rise over run. So as a fraction with the number 2, that's 2 over 1. So that tells me that I'm going to be going up 2 and to the right 1 for my positive direction. So we can just bounce count that. Start at the purple dot, start at your y-intercept, go up 2, and then to the right 1, and that's my second point. And even though we only need 2 points, I'm just going to keep going here. Up 2 and to the right 1, and we just keep going. Up 2 and to the right 1, up 2 and to the right 1. Now, if you wanted to, see all these points are here and they're all to the right of the graph. The line doesn't just stop here. There are points on this side. We just need to remember then that in order to get a positive number, we can have two negatives. So instead of going up and to the right, I can go down and to the left using the idea of 2 as a -2 over -1. So I can go down 2 and to the right 1. I can go down 2 and to the right 1, and these will all still end up connecting with a nice line. And even though you only need 2 points to make a line, the more points you have, the easier it is to make a nicer looking graph for your line. So in this example, m, our slope, is -1/3. Our b is +2. So that tells me that I'm going to start at +2 on the y-axis because that's my y-intercept, and then I'm going to use the slope. So to have a slope of a -1/3, it's either going to be a -1 over a +3 or a +1 over a -3. The negative symbol is allowed to be in both places separately, but not at the same time, because if you have a negative at the top and a negative at the bottom, you end up with a positive slope. This is a negative slope, so my line should be going down from left to right. So you always want to keep in mind what we learned about slope in the previous lesson. I should have a negative line because I have a negative slope here. So I'm going to use the fact that this would be down, my rise would be down, but my run is positive, so I'd go down and to the right. Or I would go up 1, but then it'd be to the left. So at least one of these moves needs to be negative, so down or to the left, not both at the same time. So this is what that looks like. Starting here at my y-intercept, I went down 1 and to the right 3, down 1 and to the right 3, down 1 and to the right 3. Or back up the y-intercept, I go up 1 and to the left 3, up 1 and to the left 3, up 1 and to the left 3. And notice that I used my whole coordinate grid that I had space for, but not only that, my line extends beyond those dots because you do need to understand that these lines do go on forever. So this one's pretty straightforward. For y equals x plus 3, your m is the number in front of x, so that would be a 1. Your b is the number afterwards, so it's positive 3. So you start at positive 3, and then you use the slope. So up 1 and over 1, so up and to the right, up and to the right, up and to the right, all ones to make that a fraction. And then the other direction would be down to the left, down to the left, down to the left. And again, this is from the fact that a 1 is technically a 1 over a 1, which we really need for rise over run with the slope. This one looks a little bit different, but the only thing missing here is my b. I just don't have a plus b here. It's gone. So in order for that to be missing, but to not change the value, it has to be a 0. So my slope for this one is -4, or I'm actually going to write that as -4 over 1, but my b is 0. So this is going to be starting right here in the center at the origin of the coordinate plane, and then I'm going to be going down 4 and to the right 1, down 4 and to the right 1, or up 4 and to the left 1, up 4 and to the left 1. And again, that is using the fact that I should have a negative line because my slope is negative, a negative line because my slope is negative. So this is a very steep line that crosses through the origin. So this is another example where we do not have slope-intercept form. So the very first thing we have to do is subtract the 3x and then divide by 2 so that we end up with a y equals mx plus b slope-intercept form of the equation. So once we do that, we can find, or we can see here that m is a -3/2 and b is a +6. So I'm going to start up at the +6, and I will go down 3 and to the right 2, down 3 and to the right 2, and I'm just going to go a couple in either direction, and then up 3 and to the left 2. So again, just making sure that since we have a negative slope, we should end up with a negative line, so it should be a line going down from left to right, crossing through +6 on the y-axis. Another one that the equation needs to be manipulated, solve for y, so we get slope-intercept form. When we do that, we get an equation where our slope is equal to a +1/4, and my b, my y-intercept, is a -2. So since it is a positive slope, we should end up with a positive line. Now it's not very steep at all, but it is going up from left to right, just not very quickly. Starting at the -2 because that's my value for my y-intercept. Again, going up 1 and to the right 4, up 1 and to the right 4. Whenever starting at the y-intercept, though, we'd be going down 1 and to the left 4, down 1 and to the left. So just remember to get points going in both directions, and it should end up in a line, not a V. So when we're given the graphs, we just need to work backwards. We only need two things when we're writing the equation of a line. We need our m, and we need our b numbers, because remember that the y and the x, those variables stay in the equation. We need to calculate or find m from the graph, and we need to find b also. The fastest way to start really is with the y-intercept, as long as it's a nice point, which in this case it is. So in this example, b equals a +2, and that's a point we can start at for our calculating our slope. Now if I'm looking here, it looks like they're just going up 1 and over 1 between each point. So I don't really need to count anything other than just these ones and ones. Like, I don't have to pick this point up here and then this point far away here and count this distance. You can pick the closest points. So my m in this case is my rise over run, which is 1 over 1, which is just 1. So my answer is the equation y equals x plus 2. That 1 is there, but we just don't need to write it. Starting again with the graph, the fastest thing to find is my y-intercept, as long as it is a nice point. So in this case, my b is at the nice point of -1. And then it looks like my next nice points are just a little bit away, but it looks like it's a nice even up 1 and then to the right 2. So up 1 and to the right 2. So my rise over my run, my rise was going up 1, so that's a positive 1, and my run was going to the right 2, so that's all positive. So my slope is a positive 1/2, making my final answer be y equals 1/2 x minus 1. And I know it's y equals mx plus b, but it turns into a subtraction because of the b value being negative. So please keep that in mind when you're plugging in your b value. So let's go ahead and take a look at problem C. Problem C looks a little weird because the graph is just this horizontal line, but we still remember the slope of a horizontal line. Remember, all we need is the slope and the y-intercept. So for this one, my slope of a horizontal line, all horizontal lines have a slope of 0, and that y-intercept is still right there, so my b equals -3. So we remember that we are plugging into the equation y equals mx plus b. And when I plug a 0 in for m, anything times 0, including an x, is going to be 0. So that's going to multiply out, and we're just going to be left with our b value, which is -3. So our final answer is just y equals -3. And that's going to be true for all horizontal lines. They are just going to be the y equals that y-intercept, because at every single point on this line, the y value is -3. This is the point 5, -3. This is the point -5, -3. -3, -3. That's that point right there. Every single point on this line has a y value equal to -3. So this is going to happen for all horizontal lines because all horizontal lines have a slope of 0. So all of your equations will focus around that b value. Go ahead and try D, E, and F on your own. So take the time to check your answer here with problem D, as well as problems E and F, and that's going to complete our examples for writing equations from graphs. So this concludes our video lesson for Chapter 4, Lesson 6, Writing Equations of Lines. So how do we write and graph equations of lines? Please realize that it says use the slope and the y-intercept from the y equals mx plus b slope-intercept form. Kept the examples in this lesson fairly simple as far as calculating slope goes and finding that y-intercept. So please just realize that there are some problems that you might see at some point where maybe the slope requires using that formula where you subtract the y values and divide by the subtraction of the x values. Maybe the y-intercept might take a little bit more work, but overall, these are the two things that you need in order to write an equation.